So 3 examples for the notes today. It's just a continuation of what we've been doing over the last 2 days. Notice for 1, 2, and 3, it doesn't give us any instructions. So if you look at the title, it just says that we are verifying trig identity. So if your instructions are to verify, that just means you start with either the left side and prove that it equals the right side, or start with the right side and prove that it equals the left side. Then you get to pick which side you want to work with. So you're not forced to start with the left side. So you can pick which side you want to work with and only work with that side. So don't do operations to both sides. We're only working with one side. Well, if I chose to start with the right side, I have a 1. And that, I really can't do anything to a 1. So we'll have to start with the left side and do some operations with it to prove that it equals the right side. So we're just going to put that arrow notating that I'm starting with the left side, and I'm going to prove that it equals the right side. So rewrite the left side. So we have secant squared of x is being multiplied by 1 minus sine squared of x. Now, there's more than one way to work these problems. One way you can do it is just distribute the secant squared. Or you can convert everything to sines and cosines. Or you could look for a Pythagorean identity. And if you look inside the parentheses, I see 1 minus sine squared. And what is 1 minus sine squared equal to?
Cosine squared.
Cosine squared. So this is equal to secant squared of x times cosine squared of x. Now, if you worked ahead and you change everything to sines and cosines, or you automatically distribute it, you'll eventually get to the same answer. But this will save us a little bit of time. Now, instead of secant squared, what could I change that to? 1 over cosine squared of x. And that needs to be multiplied by cosine squared of x. And cosine squared of x in the numerator, cosine squared of x in the denominator, it equals 1, which is what we have on the right side. So we started with the left side, and we have shown it equals the right side. So how many sides did I work with? Only 1. So only pick one side to work with. Looking at number 2, I can pick, do I want to work with the left side or the right side? Well, on the right side, there's not much to work with. So I'm going to pick the left side. So starting with the left side, and we need to prove that it equals negative 2 times the cosecant of x. So rewrite what's on the left side. So on the left side, we have negative sine of x over 1 plus cosine of x minus sine of x over 1 minus cosine of x. Now, in order to add or subtract fractions, what do we have to have? Common denominator. So the common denominator would have to be both of these. 1 plus cosine x, 1 minus cosine x. Now notice the first fraction, it has the 1 plus cosine x, so what is it missing? 1 minus cosine x. So that means the negative sine of x needs to be multiplied by 1 minus cosine x. And the second fraction, it has the 1 minus cosine x, what is it missing? 1 plus cosine of x. So that sine of x needs to be multiplied by 1 plus cosine of x. Now I'm going to go ahead and combine everything into one fraction. Oh, I made a mistake. What did I make? What mistake did I make?
You made it.
Yeah, this was a minus. I don't know why I put a plus, but this is supposed to stay a minus. Okay, so the denominator stays the same. I'm going to keep it as 1 plus cosine of x times 1 minus cosine of x. Now Now distribute in the numerator. So what's negative sine of x times 1? Negative sine of x. And what's negative sine of x times negative cosine of x? Yeah, positive sine of x, cosine of x. Doesn't matter which one you put first, sine or cosine. No. Yeah, when we distribute the second time, we'll have to be careful because what is it that we're actually distributing? Yeah, we need to take this negative sine of x and distribute that. So it's negative sine of x times 1. Negative sine of x. And negative sine of x times cosine of x would be negative sine of x, cosine of x. Now in the numerator, we need to consolidate. We need to collect like terms. And what happens?
Negative sine of x.
Yeah, negative sine of x gives us negative 2 sine of x.
And then the others cancel out.
And positive sine, cosine, negative sine, cosine goes out to 0, so they go away. And in the denominator, let's go ahead and multiply these because I can already see that we're not going to have any binomials cancel with the numerator and denominator. So go ahead and multiply, and what's 1 plus cosine x times 1 minus cosine x? 1 minus cosine. 1 minus cosine squared of x. Now, looking at my answer, so we started with the left side. So on the right side is our answer. Our answer has a cosecant. What's another way to write cosecant? 1 over sine. 1 over sine. So somehow I need to end up with a sine in the denominator. But do we have any signs in the denominator?
You could.
Not yet, but we could because this is a Pythagorean identity, and instead of 1 minus cosine squared, what is that equal to? Sine squared of x, and negative 2 sine of x stays the same. Now, we have some things that will cancel. Sine of x in the numerator will cancel only one factor in the denominator. So that leaves us with negative 2 over sine of x. And 1 over sine of x is equal to cosecant of x, so it's negative 2 over sine of x equal to? Negative 2 cosecant of x. So we started with the left side. We have shown that it equals the right side. Last one, problem 3. Number 3, we have the left side has some work we can do. The right side, there's really not much work we could do. So let's go ahead and do the same we've been doing. Let's go left to right. So starting with the left side, we have sine to the 4th power of x minus cosine to the 4th power of x over sine squared of x.
Doesn't the numerator equal 2? Or negative 2?
Now let me ask you this. Will the sine squared in the denominator cancel out 2 factors in the numerator? No, because down here doesn't say monomial, this is part of a binomial. They can only cancel monomials with monomials, binomials with binomials, so that won't work. So if you notice that your trig function is higher than degree of 2, or even if it's degree of 2, look to see if it factors. Sine of the 4th power of x minus cosine of the 4th power of x, what is that called? Difference of squares. So for a difference of squares, which you choose as a parenthesis, and when I square root this, what's the square root of sine to the 4th power of x? Sine squared of x, sine squared of x. One is a plus, the other is a minus. And what is the square root of cosine to the 4th power of x? cosine squared of x and cosine squared of x. Denominator stays the same right now, which is sine squared of x. What's next? Yeah, this is another difference of squares, and we could factor it again, but before that.
Can you cancel out? Or no?
Look right here.
Pythagorean, because it equals 1.
Yeah, that equals what? 1. Sine squared plus cosine squared is equal to 1. So 1 times sine squared minus cosine squared is just going to be sine squared of x minus cosine squared of x over sine squared of x. Now, looking at my fraction, I only have one fraction. But if you notice, our answer has how many terms in it? 2. So if your answer has 2 terms, but you only have one fraction, split up your fraction. If I split up the fraction, that would be sine squared of x over sine squared of x minus cosine squared of x over sine squared of x. So split it up into 2 fractions if your answer has 2 terms. Now what's sine squared divided by sine squared?
1.
1. Then this will be a minus. And cosine squared divided by sine squared is
Cotangent squared.
cotangent squared of x. So, moral of the story, see if it factors. So if you can factor, that hopefully will help cancel out some factors.